Well, Happy New Year. This is the first video of the new year. First repair, actually. And this is a Donkey Kong 2-stack Donkey Kong from Fudd over on the forums, KLOV forums. And he was having problems. First thing I spotted right off the bat was that it was missing some EPROMs in this area here. Those are the program ROMs, of course, so if you don't have those, nothing's going to happen. So before I even powered it up, I went and burned a set of those, and so those are all set. Powered it up, and that's what we get. Absolutely nothing. Now, whenever I see a screen like this, the two things I go for immediately are power. You know, is the thing getting voltage, which it is, I checked, and clocks. Because even if the thing powers up, and let's say that the CPU is held in reset, whatever garbage is sitting out in the video RAM should make its way out to the display if the clocks are running. So the fact that I don't see anything here kind of just screams that we have a clock problem. And we can test that actually. I believe for the Z80, the clock is on pin 6. So let me grab my probe here. Here's the Z80 right here. Let me kill this light so that we don't get a glare. There we go. And so 1, 2, 3, 4, 5, 6. And you can see the clock is just being pegged high all the time. The clock generation circuit for Donkey Kong is actually on the video PCB, which is down below here. So I'll have to flip this over and do some troubleshooting and figure out where it's coming from. But I like problems like this because usually, you know, something, it seems catastrophic because the entire board is dead, but really, you know, if it's something as simple as a clock, finding that one problematic IC, you know, bringing the clock back to life usually brings the entire board back to life. So let's flip this guy over and start poking around with the clock circuitry and see what we find. Well, I have my clocks back. Actually, it turned out to be an interconnect issue between the two boards. And so I took care of that, and actually in the process of doing that discovered another problem. There is a short somewhere on the video PCB between power and ground, and it's just killing the voltage. The problem is figuring out where that short is because every single one of these little ceramic caps, okay, is a decoupling cap between power and ground. So it could be any one of these guys. Now typically what I do is get a nice multimeter, not a cheap one, but something that's, you know, got some precision to it, and just start testing the power and ground, you know, either right at the cap itself or, you know, between the power and ground pins on each IC, and look for a pattern. Usually, let's say, you know, in this range it's like 3 ohms, you know, which, you know, is pretty much a short. But as I move in this direction, it might get lower, you know, it might get to 2 ohms, and then I move over here, it's 3 ohms, and eventually, you know, hone in on a spot where you think the issue may be. That's typically how I do it, and you can kind of, you know, hone in on a spot that seems to be the problem. There's quite a bit of caps here that I have to go through, so I know I'm actually not going to do this with the camera running, obviously. But yeah, so I'll start poking around here, and then I'll let you guys know where the culprit is. So stay tuned. Okay, our short has been found. The variable pots on the video board for horizontal and vertical position were fixed. Those were kind of chewed up. And here's where we are now. I can see L1, I can see 1 up, and it's flickering, and that tells me that it's probably watchdogging. Actually, we can check. I'll grab my probe, and the reset pin is, let's see, 1, 2, 3, 4, 5, 6. There we go. So that means that it's having a problem accessing these ROMs most likely. And so I think what I'll do now is I'll probably just quickly probe the chip selects and make sure that they're wiggling. And if they are, then it could be something in the addressing or data path between the CPU and the ROMs. Quickest way to take care of that is to throw the fluke on it and see what's going on there. So I think that'll be my next step. We'll bring out the big guns and figure out what's going on. Well, as you can see by this mess, I had to get quite a bit deeper into this than I originally planned. I did throw the fluke on there to verify ROM and RAM, and everything came out beautiful. And so typically in a board set where that passes all ROM and RAM checks, but it's still resetting, it's usually a problem with the watchdog circuitry. And so I pulled out the schematics and looked high and low for a watchdog, and guess what? There's no watchdog for Donkey Kong. At least not a hardware implemented one anyway. But there is some stuff up here that drives the reset, so I started poking around that a little bit more. And like I said, I threw the logic analyzer on here to kind of take a look at what was going on the address bus and whatnot. And here's what I found. So up top you can see the address, And at every time that the CPU reads from location, I don't think you can read this, but 7D00, I see a reset happen. And so I started tracing that out on my schematics here, and sure enough, there's a demux here that gets activated whenever the CPU does a read from address location 7D00. You can see the signal kind of work its way over to the reset stuff. However, that same signal goes up and activates 3P, which is a driver, which samples the bunch of your buttons, like your first player start button, your second player start button, and other things. And so that same signal that is sampling your buttons is resetting the game. And I have no idea why this is laid out this way at all. I do see a bunch of little, I don't know what you want to call them, but they're, the little connections that that someone could come and deactivate. These are like shorted, and you can, scribe them with an X-Acto knife or whatever, and disconnect them, open them up, in other words, and disable different areas of logic. Now, I don't know if they had that in there because of, well, actually, I don't know why they had that in there, now that I think about it, because like I said, these two guys are just, they're connected together, so this has come straight from the factory. These are all of those connections that I was telling you about. They're called CR4, CR3, CR2, and they are shorted from the factory that way. And so if that's the case, I really don't see how 3P and the reset circuitry could be isolated from each other without ripping those up. And so I don't know how this thing would work without resetting the game every time. And that's kind of what we're seeing. And so I think what I'm going to do is just open this guy up, isolate the reset circuitry from the button sampling circuitry, and get this thing on its feet, because right now it's just sitting there. Every time it tries to read the buttons, it resets. So let me do that, and I'm pretty positive that this will jump back to life. Yeah, exactly. See, so that is a head scratcher. I'm going to have to think about that more and investigate that a little bit more. I really don't know. I really don't know how that was designed that way. And I mean, I went over this in quite a bit of detail. Maybe I'm not seeing something. I would encourage anybody who is familiar with Donkey Kong, and in particular this section of the schematic and how that works, to go ahead and ping me. But as I'm reading this, and I got my my TTL, my Bible right here, it's telling me how these work. And sure enough, they are all working perfectly. And as the logic is designed, anytime it gets a pulse from that guy there, resets the whole thing. So I don't know, but she is good to go. I'm gonna let it play through a little bit, test out some stuff, make sure everything is working, and that is it. Another Donkey Kong rescued. So there you have it.